In this video, we will talk about the types of multi-tenant SaaS architectures. If you haven't seen the previous videos in this playlist, I recommend that you see them before watching this one. Now, let's get started. One of the most important questions among the multi-tenant adoption, which will be the multi-tenant architecture, suits better for your SaaS application on AWS. We will explore two layers needed to enable the application to act as a real SaaS platform, since that's paramount to decide which multi-tenant architecture you'll incorporate in your SaaS platform, the application and the database layer. So when we're talking about the platform, we're basically talking about two layers, the database layer and the application layer. And these two types of multi-tenant architectures are the application layer multi-tenancy and the database layer multi-tenancy. So let's talk about the application layer multi-tenancy. The application layer is an architectural design that enables hosting for tenants and is primarily delivered for software as service applications, SaaS applications. In this first model, the application layer is commonly shared among multiple customers. So the monolithic architecture for SaaS is basically, a common thing that you may fall into, where you build components and build a monolithic structure, include EC2 instances in the web tier, app tier, and the Amazon RDS with MySQL for your database. This monolithic architecture is not a bad approach, with the exception that you're wasting resources massively in the mentioned tiers. At least around 50 to 70% of your CPU or RAM usage is wasted due to the nature of the monolithic cloud architecture. So the pros can be that it's easy to build, minimal configuration, and a multi-tenant database. The cons can be a waste of AWS resources, not very fault tolerant per service. If the app tier goes down, the entire backend is down. And when deploying your code, you have to deploy all your services within the app tier and not with a specific isolated service. And it's not flexible to maintain, slows down your time to market, and there can be HIPAA and PCI compliance restraints. So let's look at the monolithic architecture diagram. And okay. Let's see if I can get this whole thing to fit. All right, cool. So here we have, like we saw in the previous video, the architecture kind of broken out as the user devices and the internet talking to our application load balancer. Now remember, we've skipped the CDN here. And then this application load balancer is talking to our two EC2 instances. And then below that, we have our another application load balancer here talking to these EC2 instances, which are talking to our S3 bucket and to the PostgreSQL master and replica, the databases. So this is kind of the monolithic architecture. Let's continue to talk about the microservices architecture for SaaS with containers and Amazon ECS. So microservices are a recommended type of architecture, since they provide a balance between modernization and maximum use of your cloud resources. So it also introduces a decomposed system with more granular services, the microservices. Now, microservice benefits are widely accepted and expressed, so we're not going to go into those details, but it's recommended to use the multi-tenant architecture with AWS services, microservices, Amazon ECS as a container orchestrator, and this entire ecosystem can work well. Mainly consider that Amazon ECS gives fewer efforts to configure your cluster and more no ops for your DevOps team. So by 2022, 90% of all new apps will feature microservice architectures that improve the ability to design, debug, update, and leverage third-party code. And 35% of all production apps will be cloud native, according to Forbes in 2019. Okay, well, we're past 2022 at this point, so I don't know what the current stats are, but let's continue. With a talented team, the best multi-tenant SaaS architecture approach would be this use case scenario. Along the same lines, it covers the SaaS software and architecture's main attributes, including agility, innovation, repeatability, reduced cycle time, cost efficiency, and manageability. Okay, great sales pitch. Let's continue. The perfect match, pros and cons. Pros are that it's loosely coupled, easier to deploy, helps better agility through smaller deployment per microservice, pure and real distributed service, repeatability and manageability, more resource utilization than monolithic. Cons are a decent grade of complexity to create the microservices architecture and the ECS clustering. Amazon ECS natively lives in the AWS cloud, so you cannot port this to other services into another cloud provider since it's proprietary from AWS. So the con is really that you do get locked into Amazon and you cannot really move things around, right? So, and that's where I like to kind of, have my own solutions of, if I'm using Redis or if I'm using Kafka or different things that I can move around and I know exactly what my architecture is. But if you're okay with being an Amazon only ecosystem and shop, then yeah, this is a great way to go. All right, so let's talk about and look at the microservices architecture diagram. Once again, we have the user devices connecting through the internet over to our CloudFront distribution, connecting to our S3 media, as well as our application load balancer, which I talked about in the previous video, so I'm not going to repeat that. And our load balancer is once again connected to our two EC2 instances with the various microservices hosted inside the EC2 services, deployed through GitHub by the developers. And that is connected to our ECR Docker registry. So the Jenkins build is essentially putting things into builds into Docker containers, and the registry is connecting that to the EC2 instances for the microservices, and this is connected back to the databases in the private subnet down here. So that is essentially our microservices architecture diagram. Let us continue on to Kubernetes architecture for SaaS with Amazon EKS. So what about Kubernetes or Amazon EKS? You might be wondering. Well, Kubernetes is another alternative of microservice architecture, which adds an extra layer of complexity, but is useful for much larger applications. And you can overcome this complexity by leveraging Amazon's EKS, which is their elastic container service for Kubernetes, the managed Kubernetes for Amazon, from Amazon, and a de facto service by the Kubernetes community. What highlights of this component from the rest of the architectures is that it provides the use of namespaces. And these namespaces can be very useful. They can aid to isolate every tenant into its own environment within the Kubernetes cluster. You don't have to create different clusters for each tenant. You could, but you don't have to. By using resource quota, you can limit the resources used per namespace and avoiding creating noise for the other tenants. Another point to consider is that if you would like to isolate your namespaces, you need to include the Kubernetes network policies, because by default, the networking is open and can communicate across namespaces and containers. So if you want to isolate the different tenants and you're using namespaces, make sure that you include your Kubernetes network policies. Kubernetes network policies. And here's a comparison of ECS versus Kubernetes, pros and cons again. The pros are the same for Kubernetes as the microservices architecture with ECS. And there's exceptional in-depth custom SaaS configuration, and it's used more by SaaS companies. Cons are that there's a higher learning curve versus ECS, and there's a re-architecture of your SaaS application. So if you have a SaaS enterprise, then you want to use EKS to be able to have that more granular control and manage that complexity. So how would a Kubernetes multi-tenant architecture look like? Here's a simple Kubernetes multi-tenant architecture and siloed by its respective namespaces. Let's look at that. So again, the internet is coming over to through our CloudFront to our network load balancer, which is now connecting to your Nginx ingress controller on your EC2 master node. And alongside you have your Kubernetes service. And this Nginx controller is now actually connecting to your EC2 worker nodes, which have containers and are namespaced for the individual organizations. And then they're connecting to the database with the details and data for that particular organization. So essentially what we did is used Nginx to kind of send people on the different tenants to the different EC2 worker nodes using this Kubernetes service. So that is essentially the architecture for Kubernetes. Now let's talk about the serverless architecture for SaaS on AWS. The dream of any AWS architect is to create a multi-tenant SaaS architecture with a serverless approach, and that's a dream come true for DevOps or SaaS architect, but it especially adds a fair amount of complexity as trade-off. And additionally, it requires a reasonable amount of collaboration with your dev team, extensive changes to the code application, and transformative serverless mindset. So given and said that, anyhow, in a few years, it will be the solution, and it all depends on the talent, capabilities, and use case. A serverless SaaS architecture enables application to obtain more agility, resilience, and fewer development efforts, a truly no-ops ecosystem. Serverless is disrupting the IT stack and used still on-premise. So go through this paper. Okay, well, we're not going through that paper right now, but let's continue with, at the high level, what are the new parts of the next generation serverless SaaS architecture. Every call becomes an isolated tenant call, either going to a logical service Lambda function or going to the database data coming from the Amazon API gateway as an entry point in the serverless SaaS application. Now that you've decoupled every logical service, the authentication and authorization module needs to be handled by a third-party service like Amazon Cognito, which will be the one in charge to identify the tenant, user, tier, IAM tenant role, and bring back an STS token with these aspects. Particularly the API gateway will now route all the tenant functions to the correct Lambda functions matching the STS token. Okay, so here we are again talking about the pros and cons of the serverless multi-tenant architecture. So the serverless multi-tenant architecture is based on no consumption by milliseconds and no more over provisioning your hardware, end-to-end serverless, microservice for each event call, no need to worry about scalability, downtime, or availability. It's all built into the serverless ecosystem, and it simplifies much more the deployments per function. The cons, again, are higher learning curve versus the Amazon ECS and adds much more complexity than previous architectures. So let's take a look at the architecture diagram. Again, we are going in through the CloudFront distribution. We've got the developers pushing builds to the Jenkins pipeline, the DevOps team creating tenants using Terraform here. And essentially, it's the same that I talked about in the previous video. Yeah, this is exactly the same serverless architecture diagram that I talked about in the previous video, with the S3 media and the load balancer connecting to the front, the CDN, and then the load balancer passing the requests over to either of the EC2 instances, which have their own microservices and connect to the caching and the databases in the layer behind, and the message queue that talks through the events. Okay, so that's it for this video. In the next video, I will talk about the database layer multi-tenancy architecture.